Hi, AP Calculus students. Welcome to Worked Out Problems for Section 4.6, the trapezoidal rule. Welcome to my kitchen. And I'm going to do all the problems from 4.6, just in case we don't have time in class to go over them, though I think we will. It is a smaller section, so I thought that this might do just as well. You don't have a quiz on 4.6, and I think you're pretty good at finding the area of trapezoids. So to end our semester, I was hoping that this would be an appropriate level to help you. So let's take a look here. I'm going to share my screen and let's try some of these problems. Okay, so on section 4.6, I haven't used my writing tablet in a while. Hopefully I will write well with this. So you had problem number 1, right? And they were asking you to use the trapezoidal rule, not Simpson's rule. You don't know how. Or if you taught it to yourself, you don't need it on the AP exam. From x squared. So the area from 0 to 2 under the function x squared and between the x-axis, and they asked us to use n equals 4. So on this problem, I'm going to kind of show everything that you could do, and then I'm going to use the simplified form, and we'll use those on the rest of the problems. Okay, so notice, because your interval is from 2 to 0 and you're breaking it into 4 sections, each of your trapezoids will have a base of 1/2. If we drew ourselves a picture of this, there we go, from 0 to 2, here's 0, 1, and 2. Oh, that's a 1 right there and a 2. Notice we'll go up to 4, right? And so let's just go ahead and draw a picture of this. So from 0, let's find the values of the function. At 0, we have 0. At 1, we have 1. And at 2, we have 4. So we know what that obviously looks like right there. There we go. And let's see, we're breaking this into 4 trapezoids, right? So here we go. So this is at a 1/2 right here. That was supposed to be a 1/2. It's hard writing small. So that would be a 1/4 would be the function value, right? That would be the value 0, 0. At 1, we have a function value of 1. At 3/2, that would be 9/4 would be the function value, because it's 3/2 squared, right? And then at 2, that would be a 4. So notice that each of these is, if you connect the first y to the second y, you are forming trapezoids, right? So connecting the first y to the second y, and you are making trapezoids here. So if you wanted to, you could do each trapezoid separately, right? So that would be the formula for the area of a trapezoid is 1/2 the base, the height, with the 2 bases added together. Okay, that's our formula that we'll be using. So that would be 1/2, right? And for our first trapezoid, the height is 1/2. And the first base is 0 and the second is 1/4. For the second trapezoid, part of the formula is 1/2, the base is 1/2, and the first base plus the second base is 1/4 plus 1. Plus the third trapezoid, 1/2 is part of the formula, 1/2 is the height. That's what I've been meaning to say. And the 2 bases are 1 and 9/4. There we go. And the last trapezoid, 1/2 part of the formula, 1/2 for the height, and the 2 bases are 9/4 plus 4. Okay. And when you do all this math, you get 2.75. What you could also do to check is, in the calculator, you could ask for the actual integration, or you could do it by hand. of x squared from 0 to 2 and see if you're close to the 2.75. Just want to point out to you, too, that in all of these, there is the 1/2, right, times the height between the bases, right? Notice I used the 0 once, plus I used the 1/4 twice, right? Plus I used the 1 twice. That's a times 1 right there. Let me cross that out. There we go, better. Plus I used the 9/4 twice. And I use the last base once. And it always goes this way. You have 1/2 times the height, and then you use the first base and the last base once and all the other bases twice, and you would get the 2.75. So we are going to use that for the next problem, which is number 5. And rather than draw a picture, I'm just going to make a chart of the points, I believe. All right, so let's go a little further down here. Okay, so on number 5, they are asking for you to estimate the area from 1 to 3 of x cubed dx. And that is where they want n to equal 6 trapezoids. So we have an interval of 2 divided by 6. So each one of our interval lengths is 1/3. Okay, so let's see, maybe we will draw a picture again, right? Let's take a look, because it's not that hard to do, right? I probably should have given myself more room right here, but we'll do 10, 20, and 30. There we go. And 1, 2, and 3. Notice we will also have a 1/3, 2/3, 3/3, 4/3, 5/3, 6/3, 7/3, 8/3, and 9/3, right? So it's going to be hard to fit all that in. Okay, so let's go ahead and let's draw a little picture here. So at 1, we have a function value of 1, right? And at 3, we have a function value at 27, right? And we know that goes kind of like that, right? And there's at the 2, so we have a 1, that would be 8 and 27, right? And then at a function value, this would be 4/3 here. That's a 4/3. This will be 4/3 cubed, right? That's a 3. My 3s are not showing up. There we go. I can do better. This is 5/3, right? And that function value is 5/3 cubed. Again, that's a 3. Let's see if I can do better. I did, right? And here is 6/3, right? That's 2. Here is 7/3. So that function value is 7/3 cubed. And then here's 8/3. And that function value, I'll just put it right here, is 8/3 cubed. Okay, let's draw those trapezoids. So there's the first, there's our first 3, there's our second 3. There we go. So here's like our trapezoids if we connect these y values here. Okay. All right, let's go ahead and over here, we'll do the math vertically for each trapezoid. Okay, so first of all, you know what? I think it's just better to go horizontally. I'm not sure I can fit it all in. Let's see what we can do here. Okay, Let's take a look. Can I still see the information? I can. Okay, let's take a look. So 1/2 is part of the formula. The height for each is 1/3. And we will use the first base once, plus the second base, which is 4/3 cubed, twice. That's a 3. Plus the next base is 5/3. We use that twice, 5/3 cubed. Good. Plus the next base is 8. We use that twice. Plus the next base is 7/3 cubed. We use that twice. Plus the next base is 8/3 cubed. We use that twice. And the last base is 27, and we use that once. There we go. And when you do all that math, you get a 20.222. There we go. Let's try number 9. I'm going to go to the next page here. There we go. On number 9, let's see. We have from 0 to 1. So trapezoidal rule again, 0 to 1 of 2 over x plus 2 squared in the denominator, dx, right? And our n equals 4. There we go. So that would mean our interval is a length of 1. So each of our heights is 1/4. Okay. And let's see, rather than draw this, if we can do a chart then, right, of all the values we need. Okay, here's our x's, and here's our f of x's, which will be our height. Let's see, so when we put in a 0, right, into the function, we get a 0 here, and that would be 2 over 4 is 1/2. Or we may go to decimals, we could call that a 0.5. Let's go to 1/4. You know, I think we will use decimals. So to get the height, I'm going to put the 0.25 in and do the math. I'm grabbing my calculator right now. And I'm going to go ahead and put that into the calculator. So that would be 2 divided by, in parentheses, let's see, that's 0.25 plus 2, right? And just making sure I'm putting it in right, and that's squared. Okay, I think I got that right. 0.395. It is just an estimate, right? So it's not too bad. Now we are at 0.5. Okay, so now I'm going to put a 0.5 in. So that is 2 divided by 2.5 squared. And that would be 0.32. There we go. 0.75. Let's put that in. Right into the function to get the height, function value. About 0.264. And last, we're going to put in the 1. I think we can do this on our own, can't we? That would be 2/9. So that's 0.222. And there's a point there. Let's call this 1/2 0.5. Okay. And then we use the trapezoid formula. 1/2 is part of the formula. 1/4 is the base. And now I'm using these heights here. Our 0.5 we use once, plus 2 times 0.395. That base is used in the second trapezoid and in the third, plus 2 times 0.32. That trapezoid is used in the 1, 2, 3rd, and 4th. There we go. Plus 2 times 0.64, 0.264. I wrote it but said it wrong. And plus the last base, which we just used once in the last trapezoid. And when you do that math, you get 0.335. All right, moving on to 49A. Let's see, 49A. Let's see what they wanted from you. On 49A, oh, they give a table. Okay. The table lists several measurements gathered in experiment to approximate an unknown continuous function and approximate the integral from 0 to 2 using the trapezoidal rule on 49A. Okay, so I'm looking at the data. I'll write the data here that I see. Sorry, I almost feel I could have had it ready for us, right? But that's okay. Let's see, it's a lot. 0, 4.32, right? So we're looking in the book here. And then 0.25. I hope I have enough room as I go across. They didn't, but that's okay. There we go, 0.5 and 4.58. There we go. Oop, drew a line through it, 0.75 and 5.79. The cat has come into the kitchen to eat. 1 and 6.14. And if you feel, you don't need this problem because you have the hang of it now, I totally understand. You can just bypass me. If you haven't, this problem, if you haven't fallen asleep already, right? 7.64. Almost there, 1.75. And 8.08. I did better than they did. I fit it all in. There we go. And obviously we have 2 and 8.14. So they didn't give us a function. They just gave us it for different x values on the function, and they're asking us to approximate this integral, the area between the function that they did not give us between 0 and 2, using the trapezoidal rule. Okay, let's go ahead then. Let's see, that would be 1/2 part of the formula times 0.25 is each of the intervals. There we go. That's a 0.25. And we are using the first base once plus the next base twice. I'll definitely need 2 lines for this. Plus the next base. This is tedious, huh? The next base twice. Plus the next base twice. Plus the next base twice. Just going to keep going. Plus the next base twice. And the next base twice. And then the last one, just once. Don't forget to multiply by the 1/2 and the 0.25 out front. And when you do that, you should get a 12.518 as your final answer. Last one, number 53. They give on 53, I'm trying to see, looking for the instructions. Let me go up a little bit more. Let's get a new page going here. I think I have another one. I do not. It's okay. All right. Number 53. Let's take a look. In exercises 52 and 53, use the trapezoidal rule to estimate the number of square meters of land in a lot where X and Y are measured in meters. Oh, shown in the figure. Okay, so I see a figure where there's a road and a stream and another road. But again, on number 53, right, we could have, I could give a list of the X and the Y. Okay, let's see. And again, if you've got the hang of this, you don't need to hang out with me. There is a picture, but I'm going to use the X's and the Y's because it worked really well for me last time. So and this is in meters, so at 0 meters, 75 feet long, 10 was 81, 20 was 84. Right. So again, as I'm filling this in, they're trying to estimate the square meters of land. You know, maybe they're putting it up for sale, or it's a new piece of land they're going to farm, and they're trying to figure out how much land they actually have, you know, how much seed do they have to buy, how many crops. And so every 10 meters, they walk out or use an instrument that measures the length of the land there. And so they want to use the trapezoidal rule, like these trapezoids every 10 feet, to estimate how many square meters of land that they have. And let's see, hopefully I can almost fit this in. Not sure how it goes. And then 110 and 123 and 23. And then they get to the end, 120 meters, and that's where they're at 0 again. So trapezoidal rule, notice 1/2 is part of the formula, right? The height between these bases is 10. The first base I'll use once, the second base twice. So each of the bases, I'm going to put 2 times that. Hopefully I don't miss one. And of course, the last base, when I get there, I will just write once. Let's see, that was a 60, 68, 2 times 67, 2 times 68, 2 times 56. Let's scribble there. There we go. 2 times 56, 2 times 42, 2 times 43. And then we'll just use the 0 once. Let me see if I had the right amount. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Wow, I'm missing a lot. Okay, what did I do? 75, 81, 84, 76, 67, 68. Oh, then plus 2 times 69. I missed a lot. 2 times 69. Then I missed 2 times 72, 2 times 68. There we go. And now I had the 56, 2 times 42, 2 times 43, and 0. So I'm sorry they're out of order, but I think once I was right here on the 68, I felt I was right here. So I missed some in between. So I put those at the end. But easy math. And when you add all that up, and don't forget to multiply by the fractions at the front, you have 7,435 meters squared. There you go. So let's come back together. And that was a lot, but tedious, but easy once you know where you're looking. Have a good day.